Yeah, let's practice using some of these limit rules. So let's say we're trying to find the limit of x, as x approaches c of the function of x to the power of 3 plus 4x to the power of 2 minus 3. Let's use the limit rule to find what this would be. Okay, we're not going to find an actual number because we're just finding c. So we know that by the sum rule, that the limit of several functions added together is just the limit of each function separately added together. So we can look at these as all separate functions, x to the power of 3, 4x2, and 3. And we can say that this is actually equal to the limit of x to the power of 3 plus the limit of 4x to the power of 2 minus the limit of 3, all as it approaches c, What we could do here is just substitute the c in for these x's because we're evaluating at c, point c. So we could say that it'll just be c to the power of 3 plus 4c to the power of 2 minus 3, because 3 is just, 3. And that's it. This is our substitute whenever we've done our limit rule using the sum rule. Get down to that this would be the same thing as this. Which, yeah, you can see. You just, substitute c for the first one. Okay, but what about the function, the limit of the function that's a fraction? It looks like this. The limit as x approaches c of the function x to the power of 4 plus x to the power of 2 minus 1 over x to the power of 2 plus 5. Well, we know by the quotient rule, that the limit of two functions is the same thing as taking the limit of both functions, the limit of f of x divided by q of x is the same thing as finding the limit of f of x and then dividing that by the limit of q of x. In this case, this would be f of x and this would be q of x. So we could say that this is actually the limit of x to the power of 4 plus x to the power of 2 minus 1 as x approaches c over the limit of x to the power of 2 plus 5 as x approaches c. But we learned from the last example that we can break these up into smaller and smaller groups, limits, going something like the limit, the limit to the power of 4 plus x plus the limit of x to the power of 2 plus the limit, or minus, the limit, minus the limit of x of 1 over the limit of x to the power of 2 plus the limit of 5. And as x approaches c. So if we have these separately, then we can just substitute x in for c for each one of these. And we get that the limit would just be equal to c4 plus c2 minus 1, because this is just 1, over c x to the power of 2, c plus 2 to the power of 2 plus 5. And that's what the limit would be using these rules. That's what we get. Okay, now what about The limit of an actual function. What about the limit? The limit as x approaches a number like 2 for a function like the square root of 4x to the power of 2 plus 3. Well, minus 3. Well, this is the same thing as saying the square root of the limit of 4x to the power of 2 minus 3 as x approaches 2. It's the same thing. I guess we can put this in parentheses. And then we know, again, we can split these up because these can be treated as separate functions. We can say, well, this is actually the limit of f of x power of 2 minus the limit of 3 as x approaches 2, all that square root. And then we can substitute in here 2 for the x's. This would just be 3, so this would just remain 3. For x to the power of 2, 2 to the power of 2 is 4, 4 times 2 is 16, so then this becomes 16. Let me put equal 16 minus 3, square root. 16 minus 3 is 13, so this becomes square root of 13. That's the limit. And I understand it's a little bit kind of ridiculous, it feels, but it's important to get these steps down and these rules down. Yeah, seems cool.